So these checklists and exam questions have come from the Forces pack. The first part of this pack deals with everything to do with the motion of objects without thinking about the forces that cause that motion. And it's primarily the equations for speed and acceleration and things like the distance time graphs and the velocity time graphs. So turning to the first question, for each of these sections you need to complete the checklist. Red means that you don't know a topic at all, so you need to go and revise it. Amber means that you know something about the topic, you're not completely sure, so you need to revisit it, recap it. And green means that you're very confident about this subject, so it shouldn't be the main focus of your revision. So turning to question 1, and it gives us the scenario and it presents us with one of these graphs. Now the first thing you'll notice is that I've circled distance on the y-axis. So I do this whenever I get one of these graphs because it's very easy to think that you're looking at a distance time graph when it's actually a velocity time graph and vice versa. So I just double check that this is about distance, and it is about distance in this case. So we have a graph, and a straight diagonal line on this type of graph means the object is moving at constant speed. This part, it's straight horizontal line, that means the object is not moving if it's a distance time graph. And a curved line on a distance time graph, either curved up or curved down, that means the object is accelerating. So the question asks, how far has the bus travelled in the first 20 seconds? So at time 0, the bus distance travelled is 0. And at time 20 seconds, I draw a line across and I read off the distance 100. So the distance travelled is 100 metres. Second question, what is the motion of the bus between 20 and 30 seconds? Well, between 20 and 30 seconds, the line is a straight horizontal line. That means the object's not moving, it's stationary. And then between 30 and 60 seconds for part 3, what's the motion of the object? Well, here I've got a curved line going upwards, so this means that the object is accelerating. The next question is a calculation question, but it asks, what is the speed of the bus at 45 seconds? Now, when you have a question like this, but they've given you a graph to use, you need to use the graph. You don't have the information to use the equation, so we're going to use the graph. Now, looking at the graph, we see that at 45 seconds, this is where the graph is curved. Now, if the graph was a straight diagonal line like this, constant speed, we can just work out the gradient of this line, and that gives us the speed. So the gradient of one of these straight lines is equal to the value of the speed. But here the line is curved, so we can't get the gradient of this line. So what we need to do is we need to, number 1, draw a tangent. So I find 45 seconds, so I draw a line upwards and find the point at 45 seconds on the curve. I put down my ruler and then I find a line which touches the point, the curve just at that point with roughly the same angle on either side. That's my tangent, and I draw the tangent. Here I've drawn the tangent as large as possible to make sure I can get as good an estimation of the gradient as I can. Because the second thing we need to do is determine the gradient of the tangent. So whenever we've got one of these curved lines where it's accelerating, we get the gradient of the tangent of the line, and this equals the speed. So I drew this very large, so it intercepts the x-axis here at a value of 11 seconds. So I'm going from 11 seconds up to 60 seconds, and it intercepted the y-axis at 185 meters. So start time was 11 seconds, the end time is 60 seconds. So the change on the x-axis was 49 seconds. The start distance is 0, the end distance is 185, so the change on the y-axis 185 meters. So the gradient of the line is 185 divided by 49, 3.8 meters per second. Question 2, also distance time graph. You'll see again, I've made sure that I know what's happening on the y-axis. It tells us the bus travels slowest between the points D and E. So we've got the part that goes from A to B, then B to C, then C to D, and D to E. Now we know that between D to C, this is horizontal, so that's stationary, but all the others are straight diagonal lines. So here we have the object moving at constant speed. So how can we tell that the speed is least between D to E? And notice we ignore the stationary because there it's not moving. Well, we can tell this is least because it has the smallest gradient. Remember, the gradient of the line is equal to the speed. So we know it's D to E because it's moving, so we're not going to consider B to C, but it has the shallowest slope. It has the least gradient compared to C to D and A to B. So that's where the speed is least. Next question asks, between which 2 points was the bus travelling the fastest? So I've got 2 choices. It's either going to be A to B or C to D. And again, the fastest is going to be where the gradient is greatest or where it's the steepest slope. So that's going to be A to B. Then it says there's a bus stop on the high street. It's marked as point B. What is the distance between point A and the bus stop? Well, point A is at 0. I can draw a line across from point B to find the distance, and that's 200 meters. So between A and B, it's 200 meters. How long did the bus stop at the bus stop? So we're looking here at where the line was horizontal. That started at 40 seconds and ended at 60 seconds. So that means that the bus stopped from 40 seconds to 60 seconds, so that's a total of 20 seconds. They then say a cyclist made the same journey, so that's travelled the same amount of distance along the high street. They started at the same time, so that's going to be the origin, and completed the journey in 200 seconds. And they travelled at a constant speed, so that means we're going to have a single straight diagonal line. So at 200 seconds, so I go up from 200 seconds, this is where they finished the journey. They started at the origin, so I draw a straight line between there and there. That's the journey of the cyclist. It then says, after how many seconds did the cyclist overtake the bus? So that's going to happen when the bus and the cyclist are at the same place at the same time. In other words, where the lines cross. So we find out where the lines cross. I draw a line down to the x-axis where I've got time, and I read off the number, which is for me 164 seconds. So the answer is 164 seconds. Okay, and you do have the mark scheme that you can also use to mark your work.